Hello, everyone, and welcome back to Learning with Jelly. Today, per a subscriber's request, we are going to discuss Way ANOVA. So, our agenda for today is that we're going to discuss the ANOVA hypothesis test. We're then going to talk specifically about Way ANOVA and interactions amongst categorical variables. And then we're going to hop right into SAS Studio to look at the syntax. So, what is ANOVA? Well, ANOVA stands for Analysis of Variance. And as you can see in this picture in the lower right hand corner, we're looking at the within group variance and also the between group variance. So, it's a hypothesis test that's going to compare the means across three or more groups. The overall null hypothesis of any ANOVA is that there is no difference between the group means. Alternatively, there is a difference between at least one of the group means. ANOVA also has assumptions that need to be intact, and we're going to talk about the assumptions for two-way in just a second. And there's also one-way ANOVA, which is focusing on one categorical predictor, versus two-way ANOVA, which is going to focus on two categorical predictors. So let's discuss two-way ANOVA. So, two-way ANOVA is going to test the effects of two categorical factors on a continuous response variable, as well as the interaction between these two categorical factors. So, for instance, you could look at gender that has two levels, males and females, and university classification that has four levels, freshman, sophomore, junior, and senior, and their effect on exam score, which is going to be your continuous response variable. You also can look at race against the categorical variable smoking status, and those two features affect on blood sugar levels. So if you have two categorical variables and a continuous Y variable, you can perform a two-way ANOVA. Now, there are several null hypotheses for two-way ANOVA tests. So the first null hypothesis is going to be that the means of all X1 groups are equal. So in this example, if you have gender and university classification, you are going to test that the means of the gender groups are equal. Next, you're going to test to see if the means of the university classification groups are equal. And then finally, you're going to test if that there is no interaction between gender and university classification. So all of these are our null hypotheses, and our alternative hypotheses is just going to be opposite of that null. Okay, so there's also assumptions that goes along with hypothesis tests, as in many other hypothesis tests. One is going to be that dependent variable, their Y variable, is continuous, such as height, weight, exam score, things of that nature. That the two independent variables that you are using are categorical. So in the previous slide, we talked about race, smoking status, classification. All of those are example of categorical variables. Each of those samples or groups are independent. Each sample also comes from a normally distributed population, and that the group variances are equal. So there are ways that you can go about testing some of these assumptions, and that will be in a later video. So once your assumptions are intact, you are now able to perform your two-way ANOVA in SAS. So the example that I'm going to show you in SAS Studio is going to take in the variable studied, which is a categorical variable of yes or no, and it's also going to take in the variable class, which in this case is going to be freshmen and sophomore. So this is a freshman and sophomore class at the collegiate level. It's also going to have your Y variable, which is score, and that's going to be an exam score. So once we create the data, in this case, I'm calling the data set scores, I then can run a PROC ANOVA. I'm going to set the data equal to my data set, which in this case is called scores. In the class statement, I'm going to have my two categorical X predictors. In this example, the X predictors are studied with the categories of yes and no. and class with the categories of freshman and sophomore. I then am going to run my model statement where your Y is always going to be on the left-hand side. So this case, score is on the left-hand side. And I'm going to set that equal to my two X variables as well as this interaction term amongst those two X variables. Because remember, we're also trying to test if there is an interaction between these two variables. In the mean statement, I want to compute categorical means for both of my variables. So I'm going to put study in class. And then slash, I'm going to do some options here. Tukey allows you to figure out what groups are actually different. And I'm also going to do some confidence limits and things of that nature. Okay. So I'm going to run that. So let's see how this actually looks in SAS Studio. So we're going to go to SAS Studio and feel free to create your own data set. I'm going to copy and paste these data lines in the description below so you can just have access to copy and paste the data directly into SAS. So the first thing that you want to do is run the data. And then after that, this is our PROC ANOVA down here, right? Where we have those two categorical variables in our class statement. We have specified our model statement that has our Y on the left-hand side with our categorical variables and interaction term on the right. And we also have our mean statement that's going to quantify the means for each one of our categorical variables, right? So we're going to run that. And here we get out some information, right? So ANOVA is based off of the F statistic, so I can get a nice little F value. I also get my P values here. So I see that the P value for studied is 0.02. The P value for class is 0.89. And the P value for the interaction term is 0.64. So in this result, we see that at an alpha level of 0.05, that studied is actually a significant variable in this analysis, whether the student studied or not, because we're going to look at p-values that's less than that alpha level of 0.05 to determine variable significance, okay? It also gives me out a nice distribution of the score versus if someone studied or not, right? And we can see here that the means, which is denoted by this diamond, they do look different, but we don't want to just rely on the graph. We want to actually look at that p-value that also verifies that these are different means, right? We also can look at a distribution amongst the different classes, and we see that the classes were shown not to be significant, and we see that these diamonds are more closely in line. So that makes sense that that wouldn't come out to be a significant variable. We have the Tukey studentized range test, right? And so Tukey will just tell us what exactly is different, if there's anything different, and tell us what the difference of the means are. Okay. So in this case, all right, we see that the studied variable is significant in determining exam score. Okay. So thank you all for listening. I greatly appreciate it. Please like, comment, and subscribe. And as I mentioned, the one-way video is going to be in the description link below. I will see you all in the next lesson. Thank you so much. Bye-bye.